Yeah, good morning from Germany. A very warm welcome at this very sunny but very cold morning here from Germany. And welcome to our product presentation, which is called PQI-LV, a new product in our product range around fixed installed power quality monitoring, especially designed for the transparency in the low voltage grid. My name is Fabian Leppich and I'm the product manager of the power quality fixed installed systems. And together with my colleague, which could be also seen here on the slide, Lukas Rappel, I support you as partners, but also you in the international sales in case of our products for power quality systems. Lukas is unfortunately not taking part right now because he is on the way to India. So he's doing his job in that way directly in front of the customer. So also from here, invitation to our fair trade in India, Electrama. Yeah, transparency in the low voltage grid. What does it mean is one thing which I want to describe today, and also combined with a short introduction to our company at the first slides. Where are we? Where is AEBALE? AEBALE has 40 years of experience in the field of measurement and regulation technology. If my mother or my grandmother is always asking me what is AEBALE doing, I always tell them we are regulating the whole German grid, maybe also a lot of European grids, but also still in the worldwide market. We are regulating the grids. This is our heart, where we come from. But in the meanwhile, we also have different other product groups which are influencing the market worldwide. We were founded in 1980. In the meanwhile, 140 employees. We are still growing in that range to achieve all your requests, to achieve all the requirements which are coming from the customers, and to provide solutions for, especially power quality measurement technology. In the meanwhile, we are active at all voltage levels in production, in transport, but also in the distribution of the electrical energy. We are international active, also via our new business development in approximately 65 countries worldwide. We are still located here in Germany, in Nuremberg. We are producing everything in Nuremberg, made in Germany, directly here in Bavaria. We are always trying to get the latest certifications, like ISO 9001. This is very easy to handle for us in the meanwhile, but a still ongoing theme is in the critical infrastructure where we deliver into is the ISO and IEC 27001, which is necessary for us to understand the management process in case of IT security requirements. Also, we get, this is not on the slide, unfortunately, in the meanwhile, an environmental certification. It's the ISO 40001. We are still getting innovation prizes. The latest is from 2025 for products, but more or less it is not a product where we get this innovation prize. No, it is an innovation technology which we provide here in the company. So a lot of guys here in the company can influence the development processes with free ideas, and this is in our main thinking. To be innovative means that a lot that the sales guys and as well as the technical guys can influence products in a really good way, that we still achieving the aim to have always the latest and newest products for you, our customers. Last but not least, we have to be open. So diversity, inclusion, equality are not just words here on the slide. We are still managing a lot of different guys here in the company. So we have approximately 30 different nations here installed. We are Kununu top company because we need we still need good ideas. We still need good employees, and for us it is very necessary to get them, and therefore we provide for our employees a lot of things, and there we are still a top company marked in Kununu. Yeah, but now coming to the point, there is an ongoing change in the electrical grid and in the electrical engineering. We want to produce, in general, worldwide scene, we want to have greater efficiencies. We want to have lower weights. We want to have a better controllability. What does it mean? So from a normal light bulb, we are changing to LED. I think that's clear to everyone. From transformer technology, we are changing to switching power supplies, right hand seen here. And last but not least, and this is the main challenging thing, especially in the field of industry, as that the motors, asynchronous motors, get more and more frequency converters, because then they are better controllability. Yeah, but at the same time, another change is coming to us all, the change in the grid. So we are, especially here in Germany, I know from many discussions worldwide that some guys of you say they cannot believe what is in Germany going on with the massive output or input of wind and PV power plants. Yes, I always say from the political discussion we can discuss, but I think the way worldwide to be CO2 neutral is a way which we should not leave, because I have childs and you have childs maybe, and there is no way to leave this way. How to manage that? This is another thing. But with the impact of so many PV power plants, wind turbines, with e-mobilities on the load side, we are also getting more and more, even in the high voltage grid, batteries. For fluctuating energies in the high voltage grid, as well as UPS systems, we get more in the grid to be more reliability, to have a better reliability. What does it mean on the grid? We have huge fluctuations in power, and this is new, I think. The fluctuation in power is one thing which we all have to be a little bit careful with. at the same time, we get more sensitive consumers, and also we get more sensitive technologies. And PV power plant is not a generator which is continuously generating 50 hertz. It is an inverter technology. It can stabilize the grid if everything is fine, but it could be also like that maybe two inverters will influencing themselves, and so we can see that the products which we put into the grid are more sensitive. We have more active control. Just an example here from Germany. In the meanwhile, if you have a house, the utility can switch on or switch off if you want to have that. Therefore, you get a better price for the energy, but they stabilize the grid by switching on and off, for example, your heat pump or your e-mobility. And what does it mean? Even in the depth of the grid, we have more active control, and at the same time, with all these influences, we get a much more increased complexity. And this have to be clear to all of us. The way out of generating 50 in big power plants with 50 hertz generator into the renewable energies increases the complexity of the system in itself, and therefore we think an answer must be to have more installed PQ analyzers in the especially in the medium voltage grid, and this is new, especially in the low voltage grid as well. What does it mean with the currents? Just one example. In the past, it was also like that. If I see we are having our office in our office building, this office is, I think, built up in the 1970s, and in these time range and climate was installed there, and this climate has an B6 rectifier. So an B6 rectifier will inject or will take the current like could be seen here. A colleague of mine, which is also familiar, very familiar, Jürgen Blum with Power Quality Worldwide, always call these currencies as McDonald's M. So you can see there is an uncontrolled recharging in the DC link, and at this time we have a non-sinusoidal current curve. The current will influence the voltage, and with which factor? With the impedance, and the impedance is, yeah, in the high voltage grid very low, in the medium voltage grid very not that low, but lower, higher, and in the low voltage grid, if you are at the transformer station, it is the highest one which you can have, and therefore it is clear that a non-sinusoidal current curve will always influence the voltage, especially in the depth of the grid. But this classical rectification will be changed actively into rectification with power factor correction. I know from my history by myself in the 90s where the PCs came up. The first PCs had this current, so the power supply of the PCs. Then they changed because such a massive numbers or increase of numbers were there during these days into the rectification with the power factor correction. And what is it? Yeah, there we have a controlled recharging of the DC link, so AC to DC conversion. But there you can see then the sinusoidal current curve have always depending on the EMC filter which is installed, higher frequency components on its sinusoidal. And this high frequency components will always influence then against the impedancy and as well as the short circuit power at the point where these component is installed in the grid, and will then influence the voltage, and these voltages can be seen then by all other consumers which are installed at the same time. And this is an issue because you know the historical things, I think. You know that in the grid, not every time everything is changing. So it is a process. And even in the EMC, so in the EMC, we are also supplier of devices, and we have to fulfill different requirements. And these different requirements are also changing. So in the meanwhile, if I produce a new product, the higher harmonics are checked. So as a sync. So if I provide a product, the product itself is source of issues and is at the same time sink of issues in these high frequency ranges. And in the past, it was not proved. And this is the main issue. If you combine an old technology, wind farm, for example, with a new technology, if you install it at the same time, then you get influences which can occur in that way that things are stopping. You have influences one wind farm to another, for example. In the past, it was also from the part of power quality that we didn't have the thresholds for the voltage. In the meanwhile, it is like that especially in the field of renewable energy suppliers, in the grid codes, a European thing, as well as I know that from other markets, in other markets also in the grid code it is written that until 9 kilohertz you have thresholds. And this is a new thing, because especially wind farms, power line communication, inverters, active filters, e-mobilities will have their DC link with these switching frequency, and this influences then other components. And it is a good decision from the standards worldwide to have here threshold limits, because why? Because then an e-mobile is also charging if a PV power plant is installed at the roof or at the household. And in the past, we could always see that this was not like that. So for you, necessary to know an IEBLE product, especially also in the low voltage grid, supports these new standards and new requirements with sustainable measurement concepts. What does it mean? Not in every case it is necessary to have higher harmonic measurement, but it must be an opportunity to take that higher measurement frequency measurement concept on the device, and therefore we provide a license model where you at every product you can see, which is displayed here on the slide, can add these technology which is needed for measuring the so-called supraharmonics. Yeah, one thing is clear. If we say we will we provide solutions for high voltage and medium voltage, the number of measuring points are not that high. This is one thing which is clear. So it's especially in the low voltage grid, the number of measurement technology increases a lot. I think you're fine with it. At the same time, due to the fact that especially in the low voltage grid, there are more consumers and the short circuit power is not that high, as well as the disturbances and the currencies are more fluctuating. So the expected disturbances in terms of amount, type, and frequency in the low voltage grid is also rising. And therefore, if we have more disturbances, if we have more higher switching frequencies, the increasing technology, the measurement technology, which we must provide as a solution provider, must be also rising. So it is very storage density. We have to, the devices must be able to record more parameters than in high voltage, because in high voltage grids, often supraharmonics 2 until 150 kilohertz are not there. In low voltage grid, 9 until or 2 until 20 kilohertz, they are there. So the monitoring technology, so the measurement technology which we put into the low voltage grid must be able to record them. And yeah, but there is one issue, because you as customers, I was worldwide traveling, always tells me, okay, Fabian, but we cannot add a high price to low voltage. And this is, I call that internally, it's the measurement paradox. And therefore, I always told my colleagues, we have to make a solution for that. It is clear that in the low voltage grid, there must be more measurement points in the future, but the price must be not that high. But the measurement technology must be very high. And I think we, as Eberle, are one of the solution provider which can deliver such an opportunity. We have, at the one hand side, for high voltage and medium voltage levels with PQI-DA Smart and PQI-DE, especially for low power ITs, low power VTs, technologies which we install, and this is good, I think. In the case of low voltage grid with these products, the price is often too high. And the point was for me to make a decision, okay, we have to bring here a product which is easy to handle, which is fleet management, which has a fleet management capability, and as well, which have to be able to be via a license model, able also to measure the main supraharmonics, so 2 until 20 kilohertz, and which is able also to monitor not only the main feeder of a transformer station, but also the feeders itself, which are going into the low voltage grid, and to provide a solution which is able to be directly in the application field. So e-mobility, charging stations, and as well, and so on. But still, there is one issue. For me, it is absolutely clear. If you have an issue in the grid, where you have to measure that issue, how to measure that issue, you have to make that always with a mobile device. And the combination of both is the main aim which we can handle with you, with also our new software which we provide this year. This is called WebPQ Enterprise. So it is possible in the future to bring in data directly from here to the software, as well as in future from here also to the software. This is a strategical thing which we internally decided, because we know the issues in the grid exactly, and we know how we have to handle that issues. It is always a combination of permanent monitoring systems combined with on-site measurements in case of troubleshooting. Yeah, what is the aim of these measurement technologies? We say it is it ensures the quality of the grid, it creates production reliability. The main aim is to measure, to recognize, and to counteract trends, and to prevent interactions between different participants which are installed at the grid at the same time. And one thing is clear: we have compliance monitoring, for example, at the point of common coupling here, directly between the industry as well as the utility grid, I call that always. And what is the application? We have to save us for external influences, as well as we have an opportunity to save us from internal influences. If there a product is installed, it is installed at the right choice of the grid. It can be in the low voltage grid with the new measurement technology PQI-LV, which is especially designed for that situation, because it is easy to install without any software. It is easy to install in case of hardware. You have to add just Rogowski coils for measurement, and all devices which Eberle provides are always Class A devices. And this is necessary because we want to compare different measurement points with each other, and we have to be reliable. And the point is, if it is not a Class A device, we will always having the same issue. You can have a Class S device combined with a Class A device, and both sides are discussing, for example, a voltage dip. And the voltage dip of a Class S device is completely different in case of the depth and the length instead of Class A. Only a Class A device is able to support and to bring out reliable measurements out of the devices. The possible applications and the possible where to install these devices. Yeah, in the low voltage grid at the stations, in PV power plants, in data centers, we install a lot of them. In mobility charging parks, in industry, directly maybe at the production line, as well as, and this is coming more and more due to the fact of the critical infrastructure in UPS systems. And for which applications? Predictive fault detections. So we can detect with the devices at an early stage issues in the grid, and then we can avoid failures. With the measures which are coming out from these devices, we can make an efficiency optimization. So you can detect energy losses and reduce operating costs. We are able with these devices to make a compliance monitoring. So you can add on the device different templates, so compliance templates, and with these templates, you can say approximately 65 industry standards we support, also worldwide, to be if the device or if the connection point is compliant with your standards. Data analysis and trend tracking. More and more coming because we are installing these devices. We have a massive data in our database, and with this data, you can make calculations better, and you can identify trends for better planning of your grid and optimization of your grid. And last but not least, protecting sensitive devices. If you have sensitive product in the industry, for example, in the depth of the grid, product processes, like in the medicine process, like in data centers, which are coming more. So you can extend the life of such products if you identify, for example, supraharmonics. Because what is a supraharmonic? I always tell to my customers, if you are flying or if you are going by train, just manage to get your power supply into your hand, and you can see what harmonics are influencing. Is the temperature, and the temperature always influences what? The lifetime. And if a network power, if a power supply is heating up due to the fact of supraharmonics, the lifetime is not reached. I've never seen an LED bulb which reaches the lifetime which is placed on the market there. And the issue is always or could be transients as well as supraharmonics. Yeah, coming directly to the device, what are the main features? 5 ones. It is in class A device according to the latest standard, and we are still in the range 0.1 of the one of the highest accuracy which we can have. It is also still a measurement device according to IEC 61858. You can measure not directly with these measurement inputs on the device, but with an external equipment, with our iSense technology, also currencies of the feeder, thanks to a generic Modbus master. And we are also here open for different third-party products. I think this is my thinking, that if you install a product and you have installed, for example, different other feeder measurement technologies, the product at the transformer station must be able also to record these third-party products and must be also able to transfer them in other protocols like 61850 or 104. It is, I think, easy to commission. What does it mean? On the device itself is a web server installed, and there are guided assistants, and there is no standardization knowledge necessary to go through these steps. So these are 3 main steps with some sub-steps which have to be done. So if you know how to surf in the internet, if you know how to connect your PC with such a device via RJ45 plug, just type in the IP address of the device, and then you are completely guided. The one big thing for us in the meanwhile, we are developing for the critical infrastructure. What does it mean? We have to have different things inside the device, like a user rights management and so on. So the main security things we can reach with the device. And last but not least, the device is more, it's a digitalization component. And thanks to our WireGuard mechanism, you can also tunnel unsecure, unencrypted protocols through our device via Modbus 104, for example, as well as other protocols, 61850, and then you have an end-to-end encryption, which is encrypted with IS 256 bits. Yeah, so one thing more, you have, this is the second point, you have the opportunity to extend the measurement technology to 2 until 20 kilohertz as an option. So if you decide, now I don't need that, install the device like it is. It's a cheap device for a power quality device with class A. And if you need the supraharmonic measurement in the future, you can do that by adding an option on the device itself. And this is good news, I think, guys, because why? You don't have to sort these product out, throw it away. You just have to install there a new license, and then with this license, the device is able to measure also the supraharmonics. And this is also like I think, this is also something which have to do with environmentally things. So we must add now products which have to be able to be extendable via licenses, because it is, I think, not a good idea to sort all these products out which are installed right now without having these capabilities. And last, another thing is, if you need, often in the depth of the grid, no fault recording is needed. The device itself will record power quality events as well, but not a real fault recorder. If you want to have this option, you can do that also via a license. The device is able to record up to 130 weeks without any communication as a black box in your grid. And this is also very good, I think, because why? We often have the issue, we will bring in devices into the grid, and at the same time, everything has to be organized. The communication must be organized and so on, to have these data then centralized in a database system, for example. With our technology, you can do that in 2 different steps. First is the installation, and then you will have 130 weeks time to prevent a connection to the device, and then you have a connection, and then the database is reading out everything automatically, and you will not have a loss of data. So it will help you to bring in devices in a much more easy way, I think. The device is able to be synchronized via NTP time synchronization. The device is having an opportunity to be directly installed in CAT4 and CAT3 systems with measurement inputs L1, L2, L3 neutral, so 4 measurement inputs. A lot of devices only have 3 measurement inputs, up to 690 volt line to line, which helps you also to provide the device into industry segment as well as wind farm applications. Yeah, from the sensor, the current measurements can be done either via Rogowski coils, very, very easy, RJ45 plug, just install that, and as well as millivolt outputs of CTs. And this is also a good, I think, a good thing, because especially in the low voltage grid, these technology is much cheaper than 1 amp, 5 amp output from normal CT technology. And we are always we have to think how to handle all these measurement equipment, and the handling via an easy to install. The failures must be very low. Failure rate must be very low in case of installation failures, I say, and the technology which we provide here for the current measurements will support these things as well. Yeah, and as I explained, we have a very high installation category, so normally no fuse is needed. I know also from the practical side, a lot of utilities will install fuses as well, but generally no fuse is needed. And it helps then also to reduce then the installation costs. Yeah, in case of IT security, we have several main features. We have an user rights management with role-based access controlled on board. So if you directly jump into the web server, you are asked for the administrator, then you can add also operators with different rights and so on. And everything is name-based via the web server. If you are thinking of scaling effects, a lot of IT guys says always a local user management on such a device is not the aim where we what we should do in the future for fleets of devices. Therefore, you have to provide a solution. We call that radius. So if you have a radius server installed, the users can be managed also centralized. The device is logging everything. So if you are logging in, the device will then write an own log file. If you forgot your password, for example, everything is logged, and this is also necessary due to the IT infrastructure where we install these devices. The firmware updates are signed. We have a brute force detection system, to prevent us from brute force attacks here. The data communication is encrypted, and we can make via these WireGuard VPN unsecure communication lines secure. And last but not least, one thing which we don't have to forget, Eberle is certificated via the ISO 27001. And so also our development processes and release processes are certificated with it. And so we are also doing a lot of in that range. And this is something you cannot see always. This is not a hard fact. I call that always, it's a soft fact, but it is a very needed feature for the future, because unfortunately, the world is looking today to me. Unfortunately, we are always attacked more and more, and therefore it is clear that we have to prevent us to be stable enough from these attacks. Which interfaces does this device? And this is another big shot of interfaces. So we have 104, we have 61850, we have this gateway thing, so Modbus master. The device is recording other devices which are installed via Modbus on the device itself, and then we can bring out the data over 104 as well as, and this is new, will come. So we have the first project with it via MQTT, so it's an IoT protocol. The device itself also has a Modbus RTU and TCP interface. It has then a REST API via HTTPS for data transfer, device parameterization, as well as the patch management. And last but not least, also the Modbus master function itself. What does it mean? It means that we can record up to 16 different other devices with such a small device. And as you can see, Communication is the key. The point is here, the device is not only a power quality device in itself. It is a PQ device as well as a gateway device, which helps you to make or to generate the digitalization in the low voltage grid. And therefore, you have to calculate. There is still clear no communication module like an UMTS modem on board or something else like that. But the point is the communication modules, if you maybe also using such a device, power quality device, where exactly a communication module is in, I always say I cannot believe that. Why? Because the communication is much faster changing than the measurement technology. So if I say such a device is installed 20 years, I'm not wrong. I think 20 years. If I think 20 years back, I'm now 40. There I was 20, young 20. I don't have such a mobile device. So the communication technology is much more changing. The measurement technology is much more stable. And it makes no sense in case of environment thinking and so on to bring that in one product together. But it makes sense to bring the communication technology, the protocols, so it's a layer on top, not the physical layer, but a layer on top onto such devices to save the number of devices. So an RTU is not needed anymore. And these are, I think, good news. We have here an RTU combined with all the other an RTU, and you don't you just have to add the physical layer onto the device, and physical layer are, I think, really cheap. What is the device doing itself? The device is recording in 7 or can record in 7 different intervals and generating continuously up to 3,800 parameters. So in 10-minute main interval, which is often used for statistical evaluation, for load analysis, for fault location, we record power, frequency, voltage, currencies, THD, THDU, and as well as supraharmonics, harmonics. This is one thing which we record here. And from this interval, we can record up to 130 weeks. In 10-second interval, it is needed according to the power quality standard, and it isn't a high-end power quality device. We can record the 10-second frequency, and this have to be recorded due to the fact of the different power quality standards worldwide. 2-hour interval for long-term flicker evaluation. Then we have a free interval. We call that internally 15-minute or n-minute interval, where you can which is time synchronized, and this is often needed for accurate check of energy meters, for active energy control systems, and so on, as well as for SCADA and fast applications. The device has 200 milliseconds, 3 seconds, and a free interval, which we call n seconds. So you can decide between 1 second and 60 seconds with all these parameters. And here on the left-hand side, you can see some parameters which can be recorded. Yeah. Here an example of our software WebPQ, where we have the opportunity to display all these data afterwards. Here 10-second frequency, voltage, current, harmonics, power, and energy in the 2-hour flicker value, for example. And this can be done out of 3,000 parameters. Yeah, it's up to you which parameters you want to record on the device. One good thing is I explained that like that there is no fault recorder inside the device in the first solution, so in the cheapest solution, but you can extend this fault recording if you want to. But in every data class, so for example 10-minute average interval, we are storing, and we are one of the suppliers worldwide. I don't know who is doing that in that way worldwide at the same time. We are recording here the extreme values, and these extreme values are based on 10 millisecond, and for voltage and current, a lot of sub-suppliers are doing that. But we are also doing that for the harmonics as well as for the power. And harmonic is really interesting, because an harmonic, the evaluation of an harmonic, also the is based on 10-minute average interval mainly, in the worldwide standardization. But I know there is an ongoing discussion, because if you switch on and switch off an inverter, like my PV power plant at home, for example, then especially in the first minutes, I have very much higher harmonics, and these are the extreme values. And you can see, for example, here an example of 3-month data approximately from the voltages, and the same you can see as well as for the harmonics in that way. With the opportunity of the feature S1, so the disturbance fault recorder, you can manage to get oscilloscope and half cycle recorders at the device. There is an opportunity to free setup, pre and post event trigger time. You have many trigger options. Voltage, in case of voltage, you can set up 2 thresholds: line to line, line to earth, step, current, envelope for transient triggering, frequency, interval, and manual trigger, as well as other automatic trigger functions which can be used. Yeah, coming to the applications, and this applications was the first application of this device. It is nearly half a year ago, and still then, yeah, quite next to my hometown, we have installed such an PQI-LV. So LV is the brand name. It is standing for low voltage into this tunnel system. This is German Autobahn, and there a new tunnel was built up, can be seen here. And inside this tunnel, there is a smoke extraction system with an emergency power system. And this emergency power system, the smoke extraction system, is using a frequency inverter to be flexible enough to bring out the smoke in a really fast way out of the tunnel in case of a fire. And there you can see the flexibility of these devices. The device is there installed for normal application, load, energy, and power analysis in the normal operation. If a fault happens in case of a power failure, as well as in case of a fire, the system is triggered, and then we can see directly the UPS system and can maybe see what's happening in that situation. If there is an issue with it, you can directly react on that issue. And at the same time, because we have an inverter installed, we at the same time have EMC filters installed. And the EMC filters, I don't know who knows that from your side, even an EMC filter has a lifetime. And what we can see, we bring in a lot of EMC filters in the meanwhile, and sometimes it happens that the EMC filter is not working anymore, and you cannot see that. You can directly only see that on the current as well as voltage supraharmonic levels, and even for this application the device is installed. So we have here 3 applications with 1 device. And this is, I think, a great opportunity to save money. Here you can see also the opportunity of Rogowski coils. So still we deliver these Rogowski coils with the device, and it's from the installation very easy. And the good thing is that the Rogowski coils also transport or are able to monitor the supraharmonic in case of the current in a real good way due to the fact of the physical principle of an Rogowski coil. It is possible to do that in that way. If you choose other current sensor technologies, it can happen that the supraharmonics cannot be measured in that accuracy you want to have that. Yeah, but in the distribution substation, you can use the device as well. So for also 3 applications, for power quality, for fault recording, as well as for supraharmonic measurement, and as an ideal head for supplying measured values for grid-orientated control over our Modbus master technology. As well as, therefore, we provide also solution with the iSense technology. We can record up to 16 feeders in case of currents, and the installation is there also very easy. Yeah, coming to the iSense technology, it is a decentralized feeder measurement solution for rebuilding, I would say, for new substations, for new transformer stations. Often the new feeders are used, and even there the PQI-LV can be the head of the communication with power quality inside. Yeah, the iSense technology itself is high compatible with the still delivered solutions, their smart PQ-IDE, and with the feature P3. It is very easy to install and to integrate, yeah, it is also reduced to the target, just measuring the current, because a lot of utilities don't know exactly the feeder currents, and the technology which we provide there is able to measure the feeder current up to 450 amp. And we have a new product as well in the pipeline, I think end of year, which can grow up in the current measurement as well as in the power measurement. Here are some examples from the first installations that you have seen. That it was a very old substation which have to be digitalized, with here installed with a PQ-IDE Smart, but it is also possible to do that via PQI-LV. This customer is using in the meanwhile the PQI-LV, and you can see the iSense is directly installed at the cable and is just plugged in a daisy chain to each other. The addressing is done automatically, and yeah, you just have to install that, make one setting inside the devices itself, and then the device itself will record the feeders to the system, and also have the opportunity to provide these data into different protocols like 104 or MQTT as an example. Yeah, some examples at the end of my 1-hour presentation. We have installed a web server on the device because we know that even in critical infrastructure, it is not allowed anymore to install software on your PCs. It is much more complex to do that, and browser is always there. And with this browser, you can set up the device completely. So the web server is there for a simple commissioning via wizards. This is the first aim of this web server. The second aim is to control the installation. So we have a live data view with different online visualizations, for example, the vector diagram of the measurement data. And the next aim is to have standard interfaces and openness for your application which you want to have. So there are new applications possible in the meanwhile, thanks to REST API. Who don't know what this is? It's not that complex. I will explain that. If you have questions to that, please write me an email, not that issue. And also over HTTPS. As an example, we call the application in that meaning black box application. So just install the device maybe on a process, on a renewable energy supply, energy park, for example. And if there is nothing, 10 years, fine, that's good. That's the best thing. If there is something, it's like in the airplane. I don't want to jump into the airplane and the black box must be used, because then I'm not there anymore. Here, it's the same situation. You can install the device. We have first in, first out black box application. And if you want to have the data, just jump into the web server and download the data in open formats like Comtrade for fault recording, to have the opportunity to provide these data also maybe to the PV power plant producer, which can then react with these informations you get him. And last but not least, the parameterization and the device management. So the complete parameterization, and this is new, is also possible via the web server, and also the device management. So device management means users and rights, system management, firmware updates, and all these things, all these applications can be done via the web server. Yeah. And last but not least, I want to tell you as well that we still have another product announcement. This is our WebPQ, and therefore we will also manage to make we will manage to make such a small presentation, like I've done that right now for PQI-LV, to show you the news as well as from our software. And the main things, so we have 5 main things which we want to manage with this new software technology. If you want to get informations here below, there are the main informations of it. So we call the software have added values, because it's not anymore about the main aim of a software is not always the analysis and reporting. In the meanwhile, we have 5 main things which a software must provide. We must have an efficient device and fleet management. We must have an automatic monitoring of many devices. We have to have an open and flexible data management, optimized analysis and reports, and last but not least, security and access management combined with audit logging and all these stuff in a centralized database. And this is, I think, really, really good news for power quality for the future. Yeah, and now I have to say thank you for your time. If there are questions, let us stay in contact. Contact us via our different channels, and we will answer all these questions directly to you and in front of you, maybe via a Teams call, maybe via an email. It's up to you. Please let us stay in touch, And yeah, I wish you now a healthy day, a healthy week from Germany, and thanks for your time. Bye bye.